Good afternoon, everyone. On behalf of PJAC, I warmly welcome you all to this hands-on workshop on open source EDA tool eSim developed under the FOSSEE project at IIT Bombay. We are especially happy to share that this is the second time PGAC is collaborating with FOSSEE, and we are truly excited to continue building this connection, bringing more such meaningful skill-oriented sessions for you all. Now it is my pleasure to introduce our speaker for today. We have with us Mr. Sumantokar, an alumnus of IIT Bombay. He completed his MTech in Industrial Engineering and Operations Research from IIT Bombay and his B in Electronics Engineering from Mumbai University. His core interests lie in contributing to open source EDA tools, and he is actively involved with the FOSSEE project. His work includes development, integration, documentation, and outreach of eSim, an open source EDA platform widely used across universities in India. What makes his work truly impactful is his focus on strengthening open technical ecosystems, enabling reproducible re-engineering workflows, and bridging the gap between academic research and community-driven software development. We are truly fortunate to have him here with us today. Sir, we warmly welcome you and invite you to begin the session.
Thank you for the warm introduction from PGAC. And yeah, so I'm Sumantha, and welcome to this hands-on workshop on the open source CDA tool eSim, which we have developed at IIT Bombay. It's developed by the FOSSEE team. So I will be briefing out what all things are there in FOSSEE and different things about eSim. So about me, so as Garima said that I did my tech from here in IUR department and B from electronics engineering and my interests are into open source EDA tools and conducting different workshops related to open source EDA and my hobbies are music, art, and electronic stuff. So here is my LinkedIn ID. If you want to connect, please feel free to scan it. And yeah, this is my email ID and mobile number. So about FOSSEE. So how many of you in this room has heard about FOSSEE? Okay, quite many people. So FOSSEE stands for Free Library Open Source Software for Education. So it's a government of India funded project funded by Ministry of Education, and it's basically for training, skill development, and our website is available over here, https://fossee.in. So do visit our website. And these are what we offer. So Scilab, Python, eSim, Floss Arduino, then OSDAC, DWSim. So OSDAC and eSim are developed by us at IIT Bombay. And I guess Scilab workshop is already done. And open form, I guess, right? Yeah. With PGAC. Yeah. So yeah, now it's time for eSim. So we will be conducting eSim workshop. And yeah, so all these tools are open source, free of cost, available free on our portal. And you can go and learn it. So these are the substitutes. So many of you might be using MATLAB. How many of you have used MATLAB in your curriculum? So those are IT. You must be knowing how much cost. You may not know how much cost the institute pays for MATLAB licenses. So, but Scilab is free of cost. So just out of curiosity, just go to the MATLAB website and check it out how much this online licenses cost you. Okay, so now Scilab can be alternative to MATLAB, and the money which your institute pays to buy the licenses of MATLAB can be used for other things like your stipend maybe or some other things. So that you can enjoy a bit more, or the infrastructure is a lot many other things it can be used for. And R versus SPSS. So SPSS is a software. I guess we received a mail quite a while ago that related to IBM SPSS. You can refer to that mail and see how much institute is paying again. Instead, R is a substitute to SPSS for statistics, data analytics, and so on. Now this open source hardware Arduino. How many of you know used Arduino? Okay, great. So Arduino, the commercial version is not written, but if we look into PLC systems, there are Siemens and of many other things, which cost you a lot of things, a lot of money. But Arduino is rather low cost alternative to a lot of things, and it's open source. So the code is available online. You can download it, around with it, and yeah. Obviously, published papers, no one will ask you that. So you can refer to licenses. And JMOL and ChemDraw. So these are for science students. And DWC, anyone from chemical background? Okay, so this is for chemical people. Open Modelica is a general modeling software. It is interdisciplinary. Even people, mechanical, chemical, all people can try out this. It's a modeling software. You can model different differential equations and things like that. So this the commercial version is Diamola, Console, and Multiphysics. But Open Modelica one can try. OSDAT, anyone from civil? No one is from civil, but you can refer this to your friends. This is developed at IIT Bombay by FOSSEE, and Professor Siddhartha Ghosh is working in this, is leading this project at OSTAT. And we have Ram. It's for basically for structures, steel structural design. We also have GIS. Anyone works in the field of GIS, Geographic Information Systems? Okay, so you can refer to our portal. We conduct hackathons and different other activities, basically QGIS. So activities promoted by FOSSEE, we have different things like case study project, where you can take up a case and submit it on our case, maybe anything, maybe a paper or something, and propose it on our portal. And once our team approves it, then you can work on the case, and then you can submit the solutions for that. Then similarly, we have research migration project. Research migration project basically focuses on paper. So if you have some paper, then you can submit. If something is done using proprietary software, and you can convert it to open source and then submit it on our portal. Similarly, we have textbook companion project for converting textbooks. So, how many from electrical? Can you raise again? Okay, so we used to have a very famous book called B. Theresa for electrical engineering. All branches of engineering might have left it in India at least. And for EDC, we have electronic devices. There is a famous book by Wallster, Robert Wallster. So yeah, so such books contain examples, and so the contributors can convert it into the open source. They try those examples and submit it on our portal. And similarly, we have lab migration project for converting labs. Whichever labs you do in your curriculum courses, maybe data structure lab or for computer science people, data structure labs. So for electrical people, we have electronic devices and circuits labs. And yeah, so different people have different labs to get it done. And similarly, for other niche areas, flow sheeting project is for chemical, circuit simulation is for electrical, then science and concept map project is for science students. So we also offer semester-long internships, summer fellowships, winter internships. So just check it on our portal. And we have some another project called the Spoken Tutorial Project. Earlier it was a part of IIT Bombay, and it's currently a part of a company called Epidemics based in IIT Bombay. And Professor Karan Magbalya of Chemical Department, who retired in July, is currently running this. And one can learn. So it's a self-based multilingual. It has self-based multilingual courses, and it has side-by-side learning practice. Like you can watch the video at one side, and you can practice the tutorials on the other. So these things and various disciplines of engineering, pure sciences, different things can do. Yeah, by the way, those with the laptops, I will be covering all the basic things, like what is there in eSim and FOSSEE for an hour, for 45 minutes, and then we will move on to the hands-on session. Okay, so now, so why India needs to lead in semiconductors? So moving into our electrical engineering domain. So yeah, so India doesn't I would say is trying hard to get into the fabrication and of chips, and yeah, so India has a lot of talent, lot of people, but as we have seen during the COVID era, there was a huge shortage of chips 6 years back. So to try hard, we need to look for the semiconductor manufacturing. There is only well-established lab in India, SCL Chandigarh. How many of you know about SCL? Any chance? Semiconductor labs Chandigarh. Okay, so yeah, so SCL Chandigarh, and yeah, so we need to try hard to get into the semiconductor manufacturing. Now, Indian semiconductor mission, so build. So government has invested a lot for domestic design and manufacturing ecosystem. Then having skilled semiconductor workforce and achieve this Atma Nirbhar Bharat mission. Challenges are like the EDA tools, the simulation tools, which are there currently, like Cadence, Synopsys, and so on. Those are very much costly. And if half of the money goes there, then we won't have enough money to train people. So, and yeah, again, limited access to academia. Again, institutes like IITs, NITs might afford this, but the three-tier colleges may not. Again, IITs are paying a lot of money to these commercial EDA tools, which can be used in other domains of expertise, other work for things. So so how our team contributes? So democratizes this chip design. We want everyone to design chips, and skill development through this open tutorial platform, basically, and supports innovation. So yeah, so our thing is open source. You can come in, create a pull request, and you can contribute. And ecosystem collaboration. So collaborating with different institutes throughout the country, organizations. So impact and way forward, design ecosystem, the skilled manpower, R&D, research freelance. Okay. And yeah, our team. So I myself, I'm part of the eSim team with Shanti Priya and Bharat. As part of the eSim team, we have senior managers, Usha madam and Vinita madam and Pai madam. And the principal investigator, Professor Prabhu Ramachandran is leading this project. Earlier it was led by Professor Karan Magvalya, as I said, who is currently head of spoken tutorials, but he retired. So after this, it's taken over by Professor Prabhu. And yeah, so eSIM, so basically this is a tool, this is a software tool, let's say it's a bundle of tool which integrates other tools. And we have developed it in IIT Bombay, FOSSEE, and integrates other tools like ECAD, HSPICE, Validator, Makerchip, GHDL, Open Modelica, and lot many things coming up. And it's released under JNU GPL, JNU Public License version 3. Okay, so you can look for the different open source licenses like MIT, Apache. So it's like that, it's GPL version 3. So features of eSIM, schematic design. How many of you have used CAD VD tools for whatever academic purposes or anyone? Electronic design automation, simulation tools, CAD, SubCAD, PSpice, Multisig, which one will you use? Windows, 55 started. Yeah, let's have it a bit interactive. We are 10 people, so we can interact with. Yeah, okay. So, anyone? Okay, so similar to a multi-sim and organic piece credits and all, which are proprietary. This eSIM is has the following features: schematic design, spice simulation. Spice is kind of code you can say which connects to points, different points. Digital simulation, mixed signal simulation, and the PCB designing, device modeling, sub-circuit designing. You can see the integration with various process design kits. We have integrated system with Skywater PDK, which is from Google, and also we have it integrated with ISP, work in progress for the global foundries 180 nanometer PDK, 180, yeah, and then yeah, so and we support Ubuntu, Windows, and we have this Docker support as well, and interface with OpenModelica, schematic converters, PSpice, APSpice, to eSIM. So basically, it converts to the schematics. So schematic is nothing but the circuit drawing, which you do on your computer, and it gets converted to our eSIM equivalent file format automatically. And the cloud version of eSIM is also available. eSIM on cloud because we have named it as. And we are also developing this AI chatbot and debug support. So yeah, and yeah, not many things. So this is the startup screen. This is the schematic editor, and this is the promo video. Okay, now different activities on the eSIM. So as we have seen different activities on the FOSSEE, so some of them. So circuit simulation project is a niche activity under this eSIM project where the contributors, students, faculty members, or anyone else will contribute a circuit to our platform and submit a proposal basically. And after that, after our team verifies the circuit, they can work on the proposal and submit the solution with the project files, and they receive a certificate and recognition on our website and some amount of money. And we have around 300 plus verified. Actually, it's now currently around 400 verified submissions throughout the country. Now there is something called as lab migration project. This is basically for faculty of postdoc or PhD people. So yeah, so this is a lab migration project where the faculty people can take up different labs. For example, electronic devices circuits labs, and do those labs using our tool and submit the solutions on our portal. So they can submit the complete lab basically, and they get a certificate and recognition on our website. So we have 8+ labs from different institutes. And eSim Marathon, so we have a hackathon activity running every year or so. So there are thousands of people participating, and we have 100+ winners every time. So we had one in 2021, then 2022 we had 2 hackathons, then 2025, and we have 2,000+ registrations and around 100 winners. And around 90 from the earlier marathon in 2021 and 2022, we had actually sent some of the designs to tape out to Google eFabless Foundry. And for the 2025 hackathon also, we are trying to have some funding and send it to the ISP fabrication in Germany. So yeah, research migration project, as I said, one can take up a paper, maybe people will get guidance, some synopsis, some other tool. And there are numerous papers available on IEEE platform. So they can try out circuits using eSim, and they can propose it on a portal. And they can even again write a paper and submit it on IEEE, so it will be an advantage. So yeah, so you need to take things from reputed journals and submit it. So this is the newly started activity, and around 150 submissions are there currently. So conducted activities under eSim fellowship 2026 will be upcoming. So how many BTech level people? Okay, so you can apply for the fellowship. Even tech MSc people can apply. It will be soon advertised in March and April beginning. So just keep an eye on our website. And semester long internship spring is currently going on, and we have around 40 interns working with us. And winter internship we have concluded semester long, so around 30-40 people have already worked with us. And yeah. So, and we also conduct workshops, conferences, our team, and in collaboration with some organization like PGAC so generally we conduct 4 workshops per month, not week. So you can yeah, look into our website like scanning this QR code.
Somebody has asked on the chat if anyone can join for summer internship during Human Design.
Yeah, so the summer internship begins in the mid-May and it goes till around July. And it's in hybrid mode. So depending on your requirement, you can work online or offline. Okay, so moving on. And then learning eSim through spoken tutorial videos. So you can scan this link, this QR code link, and you can learn it afterwards, apart from this workshop. Yes, our outreach marathon, 20,000+ registrations, 100+ winners, 9 designs sent to fabrication, and different people have published papers. Repository of we don't have this NDA business and all, so you can easily publish papers. And this repository of 600+ certificates contributed from India and abroad. And internships, we have 100+ fellows interns in 2026 and 2025. And conducted webinars to different platforms. Then we had a hardware workshop and in 3,000 participants in 2019. Some part of the workshop was, I guess, even sent to Myanmar. Yeah, so hardware workshop was one of the points, and postal campaign to reach out to different people. So this is an old thing. The different institutes throughout India, how they contribute to circuit simulation project. and different stories. So this eSIM was earlier called as OSCAD, open source CAD, and it was renamed to eSIM because the ORCAD people were a bit annoyed since it named similar. So Setanan thought to change it to eSIM. So such was the impact that they were scared of our this thing. And different other people benefited from our activities by participating in fellowships and internship activities and marathon. So, so our collaborators, we have started this faculty industry partnership program. We have some people from industry, and earlier we collaborated with Google Skywater. We are also collaborating with ISP. We are also in touch with IEEE EDA and IEEE Bangalore. And yeah, kind of we are part of ISN, India Semiconductor Information. Professor Shakti, Shakti and Ajit are also working on ISN. So yeah, you can then contact us and get them installed. Our managing strategy, so we have a principal investigator, then senior manager, then our team members, then teaching assistants, all students, and students, interns, fellows, whoever. So this helps us to have a kind of bottom down approach and agile method of having different people in team. Basically, sustain that kind of activity. And join the hands, like how will you contribute to this? So eSIM on all Linux distros. So we want it on all operating systems. So it's currently there in Linux, and we're also developing Flatpak and Snap versions. So we need people to test it out. So yeah, so whoever joins our internship programs are divided into computer science and electronics domain. So these are the computer science. So supporting the cloud version, developing on top of it. Then porting to KiCad 5, KiCad actually the upper version now, KiCad 9. Then improving the UI, fixing the bugs, integrating with OpenLane, OpenRoad, and package manager, even other things. There are a lot of things going on. Chatbot is another thing. Then so for electronics domain, designing integrated circuits, then microcontrollers using eSIM, and power electronic components, electrical components, RF circuits, and different things. Okay. Yeah, so you can visit our repositories. So you can scan this QR code. Yeah, by the way, you can contact us on this following website. If anything, any query, contact-esim@fossee.in. I'm sharing my screen. So you can visit the FOSSEE website. So for FOSSEE, there is this internships tab, and there are different internships available over here. So semester long, winter, semester long internship, autumn. So this semester long means the spring one. Spring happens in January to March, April, May, and autumn is around June, July, August to December or something like that. And summer fellowship happens in the month of May to June, July. So basically, 1 month before, you should keep an eye on our website and yeah, keep checking on our links on this website every time. We also post it somewhere over here at the top, and we also have a LinkedIn page. Um, so you can follow this page. Yeah. Here we post all the details of internships, hackathons, all the activities basically. So yeah, definitely you can contact any of our team members. We are there. Yeah, so just take this link, and on those in the online, just follow this page, and yeah, you will get all the updates related to FOSSEE. Okay, so now moving on. to the workshop. So let's go to the eSim website. How many of you installed? Those in the online people, I cannot see you. So how many of you have installed eSim? Can you raise your hands in the online Zoom meet? Just click this button to raise your hand. So just go to this page esim.fossee.in, downloads, and yeah, install it. So if you are on Windows, just click on this, and the installer will be downloaded in some time, and then run that installer, and you will have the eSIM installed on your desktop PC. If you have Windows, just download the zip file and run the .sh script, and you will get it. And for Docker, just follow the details given on the link, and you will have the Docker thing running. If any issues, just message me, uh, message over this Gmeet link. So everyone got this page. Now let's create a new project. So click on this button. Let's type suppose RC. Let's do a simple RC circuit and click on OK. Okay, just double click on this to select it. Click on the first icon in the left toolbox, left menu bar, sorry, left panel. Click on this open schematic. Okay. Now click on yes. This should appear for you. Click on the following third component from the third on the right hand side panel dialog box. Got this? Click on this red triangle shaped icon from the right hand side panel. Okay, just type eSIM underscore R. Okay, and click on OK. And place this component on the window. To zoom in, you can click on this plus button, magnify plus button between inside a magnifying glass. That's it. Okay. Okay, now adding so we have added a resistor. Now let's add a capacitor. Same underscore C. And just place it here. Okay. I'm just placing a pulse source. Placing it over here. And I'm also placing a ground. eSIM underscore ground. Okay. I'm placing it over here. So I'm waiting for some time for everyone to reach up till this step. Okay, so I hope many of you have reached until this step. So just adding another symbol called as plot underscore v1. So just placing it over here for the output plots, and another plot underscore v1 on the input side for the input plots. Okay. Now we also need to label the plots. So for that we are using this global label. So just type in and press OK, and press it over here. Place it over here. Just type out. Okay, and place it over here somewhere. So you means So in spice, these are like designators. So C means capacitor, R means resistor. Similarly, U are some predefined components which are understood by spice or eSim in general. So, for example, if you have some integrated circuit or something like that, integrated circuits are generally sub-circuits, but there are some predefined components like digital blocks and so on. So, for that, U is used. So, on data stages, while doing eSim and all, U is useful. Okay, so let's connect these components. To connect, just press W and connect. Drag and connect. W, the wire starts, and let's pull it here and connect. W, connect. Then W. Keep saving your file by doing Control plus S. Okay. Okay, so I think everyone is done with the connections. So now let's edit the component values. So just move your cursor over this eSim underscore R and just press E for edit. So just type 1K. 1K stands for 1 kilo ohm resistor and click on OK. And similarly for capacitor, just do the same thing, press E and type 1 micro. And again, press OK. We will be changing the value for the pulse on the later stages. Now let's save the file. Okay. Okay, so I hope you have completed this. So let's go to File, Export, Netlist. Okay, File, Export, Netlist. Okay, then go to this Spice tab. Not sure if I can enlarge it. Go to this Spice tab, then Export Netlist and save. Annotate, yes, annotate. So now you can see U has become U1, U question mark has become U2, R question mark has become R1, C question mark has become C1. So now save this schematic, Control plus S and minimize the window and move back to this eSIM main window. Left click, save and minimize. Right click and refresh. Again, I'm saying right click and refresh. So you should have this .cir file, .keycad underscore sch file appearing in your project list, project files list. Okay. Now click on convert keycad to ngSpice button, left hand panel as the second one. And just give the values, stop time 0, millisecond, step time 0.1 milliseconds, stop time maybe, yeah, maybe 50 milliseconds. Okay. Start time is for 0 milliseconds, step time 0.1 milliseconds, stop time is 50 milliseconds. Okay. Now go to this source details tab. Initial value 0, first value 5 volts, just type 5, delay time 0.1 n, n stands for nano, rise time 0.1 nano, hold time 0.1 nano, pulse width 1 milli, period 1 milli. Okay, now just to check everything is fine. Let's see the EdgeSpice tab, EdgeSpice model tab. Nothing is there. Device model, we don't have any device model. Sub-circuits, we don't have any sub-circuits. Microcontroller, okay, so everything is there. So click on this convert button. This dialog box will appear. The KiCad to ngSpice conversion completed successfully. Click on OK button. Okay, so go to this left hand toolbar again and left hand panel and click on this simulate button on the left hand panel. And do you want ngSpice plots? So yes. Okay, so we have got the plots. These are the resistor, capacitor, charging and discharging plots. Transient. Okay. One can even play around, zoom in, zoom out, try out different things. Find out dy by dx, zoom in to plots. Yeah, try out different things. We also have this Python plot. So input plot. This is the input. And just unchecking the input so that you can view the output. So output. Okay.